Good afternoon, all. Am I audible?
Yes, sir.
Yes, sir.
Good morning, sir.
Good afternoon.
Yes, sir.
Yes. Good afternoon. I welcome all of you for the today's class. With regard to the discussion in the previous class, I think we talked about the inversions of 4-bar mechanism and type 1 and type 2 linkages, correct? Okay. We can continue the discussion today also. Just we can have a quick review about the previous class. So we discussed about the 4-bar mechanism. So what is meant by 4-bar mechanism? We are having 4 links in that mechanism, in which we are having the fixed link is called a frame. A rotating link, that is 360-degree rotating link, is called a crank. So here crank is assumed to be S, and the link which connects the input link. So crank is your input link, and this is your output link, or which is called as rocker. So the link which connects your input link and output link is called the coupler link. Okay, and we in order to have a mechanism, at least one of the links should be fixed. Here the frame is assumed to be fixed. So now we can get a mechanism whenever we are giving input to the crank, so that we can extract some output, some predictable output in the output link, that is rocker. So we discussed about the different inversions of the 4-bar mechanism. So inversion means fixing one link, and we are going to observe what is going to be what is the mechanism or motion that is going to happen on other links. So the criterion that we used is the Greshoff's inequality criterion, that is S plus L is less than or equal to P plus Q. What is S plus L, Pa? What is S plus L?
Sir, shortest link plus
Shortest link of largest link.
Yes, the length of the smallest or shortest link plus and the largest link should be always less than the other two links which are used, that is P plus Q. So in this case only, if this criterion is satisfied, means then we will be getting at least one of the links will be rotating 360-degree. So other one the cranka we can use it, because whatever the prime mover we are using, that is input through the prime mover, is going to be a rotatable form, that is a continuous rotation form. So continuous rotate agano. So in this case, if this criterion is satisfied, then we can make at least one of the links rotating through 360-degree, so that the input can be connected. So if this condition is not satisfied, that is S plus L is greater than P plus Q, we need to have non-rotatable links, continuously rotate agadu. So in that case, connecting the prime mover with the one of the links is very difficult. So we need to have some alternate arrangements, since linkages have no rotatable joints. So we discussed about the Greshoff type 1, that is first criterion S plus L should be less than or P plus Q. In this case, we discussed 4 inversions. So that is first inversion is fixing the link which is adjacent to the shortest link. So here the shortest link is S. So adjacent to the shortest link is Q. So either fix panna, we obtained crank rocker mechanism. Crank rocker mechanism, which means that crank is this one, which is making this particular path, which is tracing this particular path. It is rotating 360-degree, and your rocker, that is P, this is your rocker, it is going to oscillate. It is called crank rocker mechanism when the shortest adjacent to the shortest link is fixed. So we are having one more link which is adjacent to the shortest link, that is L. So if this is fixed, again this is going to be the center of rotation, and this point is going to trace a circle like this through 360-degree. It is going to rotate 360-degree, and if that is the case, your rocker that is this particular point, is going to make oscillations. So in this case, Q is going to be the coupler. In this case, L is going to be the coupler. Okay. So this is the first case. So we will be getting at least one of the links are going to rotate 360 degree. So when the shortest link is fixed, so you will be getting what? When the shortest link is fixed, what is the mechanism you will be getting, Pa?
Rocker.
Double crank mechanism, sir.
Yes, it is double crank mechanism. So ரெண்டு லிங்க் வந்து 360 degree rotate ஆகும். எப்போ? When the shortest link, இதுல எதுப்பா shortest link? This one. Shortest link வந்து நீங்க fix பண்ணீங்கன்னா at least two of the links will rotate 360 degree. So you will be getting double crank mechanism. When the link which is opposite to the shortest link is fixed, எதுப்பா shortest link opposite ல இருக்கிறது? In the first case, it is P, correct or not? So shortest link straight opposite it is P. So assume this P color, this black color is your P. So it is fixed now. In this case, you will be getting what? Double rocker mechanism. Double rocker mechanism. So we have seen few examples for all of these cases. And if it is Grashof type 2, that is the inequality condition is not satisfied or it is being violated, that is S plus L is greater than P plus Q. In this case, in the link 4 bar mechanism, in the link when you fix pannalu, you will be getting only rocker mechanism. So if you assume this link is being fixed, okay, the fix pannada assume panninga, so input inga kudukrada vechitingna, okay, so this link is going to make rocking motion and correspondingly this link is going to make rocking motion. Similarly, இதுக்கு opposite. So this is fixed தான் assume பண்ணிட்டீங்கன்னா input is given to here means this is going to make rocking motion and correspondingly this is also going to make rocking motion and so on. So in the link fix பண்ணாலும் you will be getting only rocking motion. I think I made some mistakes in the problem. I don't know how many of you left before clarifying the doubts. Let me solve this problem again. Okay, so we need to understand what type of mechanism it is, okay, and what category it belongs to. So these are all very important. So now, okay, let me repeat it again. We know that Grashof's criterion, sum of smallest and largest should be less than or equivalent to other two links, P plus Q. Which is shortest link in the first case? A.
5, sir.
5 is the shortest link. And which is the largest link?
9.
So 5 plus 9 should be less than or equal to P plus Q. Other two links are 7 plus 6. Okay, so 5 is the smallest and 9 is the largest. So let it be 7 is P and 6 is Q. So check whether this condition is satisfied or not. So it is 14 less than or equivalent to 7 plus 6, 13. So the condition is not satisfied, correct or not? Is it correct or not? 14 is less than 13 was it? So the condition is not satisfied. So it violates, so it belongs to type 2 category, or it belongs to non-Grashof linkage. Non-Grashof linkage. So என்ன மெக்கானிசம் கிடைக்கும்? எந்த லிங்கை ஃபிக்ஸ் பண்ணாலும் டைப் 2ல எந்த லிங்கை ஃபிக்ஸ் பண்ணாலும் என்ன மெக்கானிசம் கிடைக்கும்?
4 bar
rocker. Yes, rocker or double rocker, whatever you can write, it is correct. Rocker mechanism you will be getting. Now coming to the second case. Okay, second case சொல்லுங்கப்பா. Which is smallest?
4, sir.
4 sir.
Largest pa?
9.
sir.
So 7 plus 7. Please mute. 7 plus 7, 14. So here 13 is less than 14. So the condition is satisfied or not? Yes, the condition is satisfied. 13 is less than 14. So it belongs to the type 1 criterion, that is a type 1 mechanism. So it is called type 1 or it is called Grashof linkage because it is obeying the inequality criterion. So Grashof linkage. So now tell me what mechanism you are going to obtain when you are here. The fixity condition is smallest link, correct or not? So the smallest link is fixed here. Okay, it is fixed here. So whenever the smallest link is fixed in Grashof linkage, what mechanism you are supposed to get?
So double crank.
Yes,
Double crank.
it's a
Double crank.
double crank mechanism you will be getting. So when the link smallest link is fixed, you if you give input to the ninth link, 9-dimensional link, so 9 is also going to rotate completely, and this is 7, this is also going to rotate completely. So 360 rotate agum. It is called double crank mechanism. Now coming to third case, third case, 10 plus 5, correct? Smallest and largest is 5 plus 10 is less than or equal to other two links 7 plus 9. So 15, which is less than or equivalent to 16. Correct or not? The condition is satisfied. Okay, so this is type 1 or Grashof link. Now tell me what mechanism you are going to get. Which link is fixed?
Double rocker.
Yes. Which link is fixed?
Sir,
Largest
9.
link.
9,
Large.
sir.
9, sir. Intermediate link, sir.
Intermediate link, the link which is opposite to the smallest, opposite to the smallest link. So in this case, you will be getting what? Double rocker. So double rocker kadaikum. Okay. Now the last case, 4 plus 10 less than or equivalent to 7 plus 8. Tell me in which category it belongs to?
Sir, type 1, sir.
Yes, type 1. What mechanism you will be getting? Which link is fixed?
Crank rocker mechanism.
Crank
Crank
rocker.
rock, sir.
8 is fixed, sir.
Yes, 8 is fixed, which is nothing but the link which is adjacent to the smallest link. The smallest link is 4. That's adjacent link 8. That's fixed pannirkom. If this is the case, if you give input to the this fourth link, obviously you will be getting 360 degree. The link 4 is rotating, and the 10th link is going to make rocking. So it is called crank rocker mechanism. So I think now you are able to identify what type of mechanism it is, whether it is obeying the Grashof's inequality condition, and what mechanism we are going to get. Are you able to understand? Shall we proceed?
Yes, sir.
Okay. I think we discussed about the inversions of 4-bar mechanism. Inversions of 4-bar mechanism. We completed, and we are having inversions of slider crank mechanism. Inversions of slider crank mechanism. We can call it as inversions of single slider and inversions of double slider crank mechanism. Okay, so a 4-bar mechanism, we know that it is a 4-bar mechanism. It is a 4-bar mechanism. How many links we are having in 4-bar mechanism, Pa? How many links we are having in 4-bar mechanism?
4, sir.
4 links.
4, sir.
4 links. So the whole thing is assumed to be frame. This is called crank, and this is your coupler, and this is your rocker.
Rocker.
So we are having 4 binary links in 4-bar mechanism. If one of the links in 4-bar mechanism is replaced with a slider, then it is said to be what? Your single slider mechanism. For example, let me keep all the links in 4-bar mechanism as it is, like So I'm going to keep this frame, and I'm going to keep the frame, and going to keep the coupler, and instead of rocker, I'm going to replace it with the slider. Okay, the slider is resting on again frame. So what change I have made, pa? What change I have made when compared to 4-bar mechanism?
ஒரு லிங்க் வந்து ஸ்லைடர்ல ஃபிக்ஸ் ஆயிருக்கு சார்.
Okay, அப்படி மாத்தும்போது என்ன சேஞ்ச் நடக்கும்? What motion you will be getting?
லீனியர் மோஷன் எக்ஸ்ட்ரா.
Linear motion.
Yes. So in the 4-bar mechanism, it is called as all are revolute pairs. Okay, all are revolute pairs, because with respect to one link, another link is going to make rotating motion. Okay, for example, with respect to the frame, your crank is rotating. With respect to crank, your coupler is rotating. With respect to frame, your rocker is oscillating. So likewise, it is called all are revolute pairs. Okay, in single slider mechanism, I just replaced the rocker with one slider. Okay, now tell me what type of motion, what type of pair it is that is between the frame and slider?
ஹையர் பேர் சார்.
Higher pair. What type of like revolute pair சொல்றோம் இல்லையா, revolute na rotate ஆகிறது. Then what type of motion between your frame and slider is?
Reciprocate.
Sliding motion or reciprocating motion. Okay, it is called sliding pair. Okay, since it is having sliding motion or reciprocating motion, so motion is different here in compared to the 4-bar mechanism. So it is having reciprocating motion. Remaining things all are same. Okay, or frame irukum, here we are having a crank, here we are having a coupler, everything same. Only thing is I'm going to replace the rocker with the slider. So your output link is your slider. It is going to make linear motion. Okay, so along the frame. So in the mari to and from motion agum. So applications on the IC engines. Okay, so likewise in double slider mechanism, two links are going to two links in the 4-bar mechanism are going to be converted into sliders. So that is nothing but your double slider mechanism. So you have a component called the assignment presentation in your continuous assessment. Okay, so I think you are going to write 3 CAs for 25 marks. So best 2 will be taken, and you are having an assessment tutorial for 5 marks, and assessment tutorial 2 for 5 marks, and assignment presentation 15 marks. So in this assignment presentation, I leave it to you for the self-study and for explanation in the assignment presentation component. That is inversions of single slider mechanism and inversions of the double slider mechanism. So 2 batches can select these 2 topics for their explanation. Okay, that is self-explanatory, you can learn. Okay, like 4-bar mechanism, these 2 mechanism, that is if this is the case, if this is a single slider crank chain mechanism, okay, single slider crank mechanism, if one link is fixed, for example crank is fixed, what mechanism is going to be obtained for what application? Similarly, if the coupler is fixed, what mechanism is going to obtain for what application? Likewise, we are having interesting applications, and similarly for double slider crank chain mechanism. So it is given for the assignment presentation component. So you make a self study on these topics. I leave it to you. So it is example for double slider. Okay, so double slider means we are having a frame, and here we are having slider 1, and here we are having slider 2, and these 2 are coupled. So slider 3. So frame is 4. So this is example for slider. So idhula only fix pannina what mechanisms you are going to get for different applications. That is very interesting to learn. Okay, next we move on to the important definition called transmission angle. So what mechanism it is, Pam? What is the mechanism? What is the mechanism which is shown in the figure?
4-bar mechanism.
4 bars.
4-bar. Okay, let me explain the transmission angle concept with 4-bar mechanism. So in which we are having 4 links. The link crank is called here A, and link coupler is called B, and link rocker is called D, and frame is called D. So normally we will be having some dimensions for all these links. So let me take the arbitrary dimensions called A, B, C, D. Okay. So in order to change the orientation of this particular links, that is mechanism, for example, I want to move B from this location to this location. So uh, either the dimensions of the link can be changed, or what is the one more variable which is required to identify the orientation of the mechanism. So look at the diagram and tell me what is the variable which is required to identify or to locate the orientation of each and every points of the mechanism. Any idea? So either you can change the dimensions of the links to have the different orientations, or we need to have, okay, so that is theta. Okay, theta, what is theta now? Let me draw it here. So it is your theta. Now tell me what is meant by theta. Look at the diagram and tell me.
Angle, sir.
Angle, what angle?
Angle.
What angle? Angle between what?
Between A and
A
D.
and
CO1 and
Tell me.
D and A, sir.
D and A. What are D and A?
Links, sir.
What links they are?
Frame and cranks.
Between frame and
Frame
crank.
and
Okay, so theta is the angle made between the frame and the crank. Okay, in order to have this particular orientation, we should have this particular theta. And if you want to change the orientation of point B, so point B in right now, if you want to change the orientation of B from here to here, somewhere else, okay, for example here, so my theta is going to vary, so to certain angle. So my theta is going to be an independent variable in this case. It is going to be an independent variable. It is normally independent. In order to change the orientation of different points in a mechanism, given mechanism. So that is theta. Okay. Now, if you look at the angle made between the rocker and the frame, okay, rotating this clockwise. Okay, this is your clockwise. So what angle it is, Pa? What is the name for this angle? It is called phi. Okay, it is called phi. That is nothing but output angle. Okay, so we know that A is your input link or crank. We can say B is your coupler, which connects your input link and the output link, and C is your output link, which is also called as the rocker, and D is your frame, or also called as fixer link. And theta and phi are your input and output angles. Now you can see another angle, that is gamma. Okay, what is meant by gamma, Pa? This gamma. Tell me what is gamma?
Angle between coupler and rocker.
Angle between?
Coupler and rocker, sir.
Yes, exactly correct. So angle made between the coupler and the rocker is called your gamma. That is nothing but transmission angle. So in this class, we are going to understand the significance of transmission angle. It's very, very important parameter as far as the mechanisms are concerned, so that we can transmit the maximum power or maximum motion to the the output link. Now, in order to understand what is meant by the transmission angle, let me give some illustrations about transmission angle. Now, assume we are going to apply some force on the input link, that is crank. Okay, so what it will do, Pa? Whenever I am applying some force or some torque or some angular motion through some prime mover, what will happen? Suppose assume
crank will rotate.
crank will rotate, or it is going to displace from this particular position. So in the A point, if I apply some torque or some force or some angular velocity that I am give through some prime mover, this point A is going to rotate through clockwise. Okay, because I am applying along this direction. So this point is going to rotate along clockwise direction. So what will happen to my output link?
அதுவும்
So it
displace
will
ஆகும் sir.
oscillate or
It will oscillate, the same force is going to be transmitted to the rocker through my coupler. Okay, the coupler is the one which transmits my input motion or input force to the rocker. So transmit ஆகும்போது what will happen? It is going to make some motions or it will do some useful work. Okay, in this case let me have some example. Assume a platform here. Okay, you are having some cotton boxes, okay, which needs to be periodically moved from one location to another location. So this is the one location where your cotton box is sitting. Okay, for periodically it needs to be moved to the another location with the help of this output link. For example, after some force is exerted on this cotton box, it is going to be moved to some location like this, some distance like this. So next cycle it is going to another cotton box is going to come. So when the rotation of the crank makes the rocker to move towards the right side, so that the another cotton box is going to move to the some specific distance. So it is a specific applications that the rocker is doing. Okay, so in this case, what is the role of transmission angle here? What is the role of transmission angle?
Transfer the motion from one
In our, yes,
It decides displacement.
yes, it decides the how much force it is going to act on your output link. So as I told, the transmission angle is nothing but the angle made between your coupler and rocker. Okay, so the coupler is the one which transmits motion to the rocker. So if you look at this particular image, you can understand when the crank rotates, the force is transmitted to the output link, that is rocker, through your coupler. So your force transmission or motion transmission is purely based on this transmission angle. So let me give some examples or some orientations of coupler and rocker, so that you can tell for which case the transmission, the transmission of force or motion will be maximum. Okay, so let me draw it here. So this is your
சார் எனக்கு கொஞ்சம் நெட்வொர்க் இஷ்யூஸ் இருக்கு சார், வெளியில போயிட்டு வருது சார்.
ஓகேப்பா, can. So this is your rocker and this is your coupler. Assume this case and another case. This is your rocker and this is your coupler. And the third case, this is your rocker and this is your coupler. Now tell me for which case your force transmission or motion transmission will be maximum, and justify that why it is happening like this. We know that the coupler is going to move your rocker. Okay, so understand the three different orientation of the coupler and rocker. In the moon case la end case la force transmission or motion transmission will be maximum.
Sir, in horizontal,
assume this case is this is the case 1 and this is the case 2 and this is the case 3. Now tell me number. In the case pa?
second case. Second one.
Someone told which one?
Second case.
Second, exactly correct.
Second case.
Yes, good, very good. Why pa? Is correct answer. Why?
Sir, sir, 1 and 3 gravity killer.
1 and 3 pa? Your answer is correct. Tell me. No, don't hesitate to give answers. If it is wrong, don't worry.
Sir, sir, கிராவிட்டிக்கு மேல வரணும் சார். ஹாரிசான்டல்னா பிரச்சனை இல்லாம வந்துரும் சார்.
Okay. Any other responses or justifications?
Sir, in second case, the force exerted will be more, sir.
Force exerted will be more. Okay. Okay, the reason is, suppose you consider the rocker. Okay, so whenever the force is applied or motion is transmitted to the rocker through your coupler, and your rocker is going to make some oscillations, correct? So it is going to make some oscillations like this. Okay, so its velocity or motion will be along tangential to this curve. Okay, so your motion வந்து இந்த மாதிரி curve இருக்கும். Okay, so its velocity is going to act normal tangential to the this curve. Okay, for example, its velocity vector will be like this. Okay, force in the direction la பாருங்க. The green coupler is making force along which direction?
Right side, sir.
Towards the same direction, correct or not? Along this direction only. Okay, if the force vector, so this is your force vector or motion vector, this is your velocity vector, okay, they are in same direction, definitely your transmission of force or motion will be maximum. Okay, in this case the force transfer or motion will be maximum. Whereas you consider the case 1 and case 3. Okay, so same case, your rocker is going to make some oscillations like this. Okay, oscillations like this. Okay, so velocity vector will be like this. Where is your force vector? Where is your force vector? This one. It is acting like this.
Upward.
Acting like this. So the deviation between the force vector. So previous case, it will be in the same line. Okay, there is no deviation. So here some deviation. So it is your velocity vector. It is your force vector. So there is some deviation. So this deviation is called your transmission angle. So whenever you are having transmission angle less than 90 degree, okay, so here it is assumed to be 90 degree. So if it is less than 90 degree, your motion transfer will be less effective when compared to the previous case. Similarly, in the case your velocity will be like this and your motion will be like this. So some small deviation we are having. Okay, wherever the deviation is there, you will be getting less effective motion transfer. Okay, so now you come to your 4-bar mechanism. So your velocity motion of your coupler is going to be along, it is normal to this link, and your force is acting through the coupler is along this direction. So this deviation is called your gamma, that is transmission angle. So it is also mentioned here. So that is the angle between your coupler and rocker is called gamma. So gamma எவ்வளவு இருந்தா you will be getting better transmission, and எவ்வளவு எந்த ரேஞ்சில இருந்தா it will be better?
90 degrees.
90 degree in the better. Okay, so between 45 to 90 it is better. So less than 45 degree it will give more deviations or less power or motion transmission. Is it clear?
Yes, sir.
Okay. So for ideal case, it should be 90 degree. Ideal case means what? Ideal case means it will be standard value. So better irukkanum neenga nenachingna, it will be 90 degree. Okay, so it is not possible to retain 90 degree between all the rotation of a crank between your coupler and rocker. It is not possible. But for 90 degree maintain agumbodhu, the motion will be transmitted maximum. So that is the idea behind this transmission angle. But we need to maintain as closer as 90 degree. So between 45 to 90 degree maintain pannina, then it is better. Okay. So it is called index of merit, or we can call it as index measure of performance. So normally, how we are measuring the performance of any system? Normally, ஒரு engine இருக்குன்னு வைங்கப்பா, எப்படி performance measure பண்ணுவீங்க?
Input by output, sir.
Output by input. Okay, it is like efficiency. So whenever we need to understand the performance of engines, it is measured with the help of efficiency. So in the same way, in order to realize the performance of mechanisms, we are having some indices of merits. So like efficiency in engines, இதில் வந்து பார்த்தீங்கன்னா transmission angle, then mechanical advantage, இதை வச்சு we can able to predict the effectiveness of the mechanism. So it is one of the indices of merit, that is called transmission angle. So we need to understand, we need to identify for what case you will be getting the minimum transmission angle and for what case you will be getting the maximum transmission angle. Now tell me how to identify the minimum and maximum transmission angle. Because உங்களோட crank வந்து it is going to rotate continuously. Okay, crank வந்து continuously rotate ஆயிட்டு இருக்கும், கப்ளரும் ராக்கரும் மூவ் ஆயிட்டே இருக்கும். ஸோ எந்த கேஸில் இந்த காமா வந்து மினிமமாக இருக்கும், எந்த கேஸில் காமா வந்து மேக்ஸிமமாக இருக்கும் அப்படிங்கிறது we need to identify. So it is not possible to just look at the image and it is not possible to tell. We need to have some analytical calculations to find out the minimum transmission angle and maximum transmission angle. எந்த orientation இருக்கும்போது minimum gamma இருக்கும், எந்த orientation இருக்கும்போது maximum gamma இருக்கும். That we need to identify. So for that we are having a small derivation. So I connect the points A and this particular point. Okay, let me erase all the points so that it will be clear. So first case I am going to connect this point A, end point of your crank and the frame O4. Okay, O2, O4 are your frame. So O4 ஐயும் A வையும் connect பண்ணிக்கிறேன். Now I am going to keep this line as K. Okay, let it be K. I am going to apply the cosine law for two triangles. What triangles we are having here, pa? If I connect A and O4, how many triangles I am having here?
2, sir.
2. Okay, what
Two.
are they? What are they?
A, O2, O4, A,
O2, O4 is yes. B, A, O4. Two triangles I am having. Now I am going to apply the cosine law for these two triangles. Okay, cosine law is nothing but if you consider the triangle O2A O4. Idu O2A O4, this one O2A O4. Consider this particular triangle alone. Now apply the cosine law for this triangle. It is nothing but the side square. So A, this is your A square plus other side square, D square minus 2 times A into D cos theta. Okay, this angle is equivalent to the opposite side square, A square. So this is your cosine law for the particular triangle A, O2, O4. Okay, similarly apply the same cosine law for the another triangle. Which is another triangle, pa? AB O4. So this is another triangle. So if I apply the cosine law, tell me what is the equation you will be getting? Side square, so B square, okay, plus C square minus 2BC cos in the angle power. This angle, this gamma. Okay, earlier case it is theta. In the triangle it is gamma will be equivalent to what? The opposite side square. Opposite side is K square. Is it correct? The cosine law for the two triangles, that is triangle 1 and triangle 2. Now you keep it equation 1 and you keep this as equation 2. ரெண்டுலயும் பாத்தீங்கன்னா ரைட் ஹேண்ட் சைடுக்கு ஈக்குவலா என்ன இருக்குப்பா? K ஸ்கொயர் இருக்கு. So you can equate the equation 1 and 2. Okay, ரெண்டுக்குமே equal to K square இருக்கறனால, so K square is this one and K square is this one. If these are all equal, then these will be equal. So இது ரெண்டையும் நீங்க டைரக்டா ஈக்குவேட் பண்ணிக்கலாம். Then what you will be getting next equation if you equate these two equations? ரெண்டு ஈக்குவேட் பண்ணீங்கன்னா என்னப்பா கிடைக்கும்? That is left hand side you will be getting this term, that is A square plus D square minus 2AD cos theta, that is written here. Okay, and right hand side you can write B square plus C square minus 2BC cos gamma, that is written here. எதனால ஈக்குவேட் பண்ணும்பா? Because K square is equivalent to this one and another equation K square is equivalent to this one. If these two are equal, obviously these two equations these two are equal. That's why I equated these two terms. Okay, now any doubts up to this, pa?
No, sir.
Okay, now I rearrange that some of the terms in this equation. So in this equation, so I return a square plus d square. I brought b square plus c square right and left hand side kondu vanduten. So that comes here minus 2ad cos theta, and I brought minus 2bc cos gamma also left hand side. So this equation becomes like this. Now I want to find out minimum and maximum value of gamma. Okay, for what case of theta I will be getting the minimum and maximum gamma. So in order to find this minimum and maximum transmission angle, I need to differentiate this equation. So the above equation. So this is the final equation you will be getting. You differentiate this equation with respect to theta. Okay, so you need to differentiate this with respect to theta so that you will be getting the minimum and maximum value for gamma. Okay, so now tell me what is the differentiation value pa? If you differentiate this equation with respect to theta, what you will be getting? Apply the differentiation rule and tell me, if you differentiate this equation, okay, this equation with respect to theta, what you will be getting? What are they? A square plus d square minus b square minus c square engrudhupa. What is that?
Sir, 2a plus 2.
Now tell me, what is a square plus d square minus b square minus c square? These are all constants, correct? When you differentiate, this becomes 0. Okay, that is 0 iron. Okay, so you will be getting 2ad cos theta. Adu enna agumpa differentiate panna with respect to theta?
minus sin.
Cos theta engadhu minus sin theta iron. So minus already one irukku, so it become 2ad sin theta. Correct?
Correct.
Okay, so inga 2 miss ஆயிருக்கு. Already இங்க ஒரு 2 வரும், அது ரெண்டே வெளிய எடுத்து ரைட் ஹேண்ட் சைடு கொண்டு போய் 0 பண்ணிருக்கு. Okay, so it becomes 2ad sin theta. Okay, and another term, this one, இது என்ன ஆகும்பா? Here we are differentiating with respect gamma with respect to theta. இப்போ என்ன ஆகும்பா?
Sir, minus 2bc
minus 2bc sin gamma, and one more term,
dy by d theta.
d gamma by d theta, because you are, yes, exactly correct, you are differentiating gamma with respect to theta, so that will come into picture. So 2 sin I'm sorry 2bc sin gamma, okay, and d gamma by d theta varum. Okay, so 2 வந்து வெளிய எடுத்து நான் ரைட் ஹேண்ட் சைடு கொண்டு 0 பண்ணிட்டேன். So the green color இருக்கிறது தான் உங்களுக்கு கிடைச்சிருக்கும். Okay, so ad sin theta minus bc sin gamma into d gamma by d theta you will be getting after differentiating the above equation. So now simplify this equation again. Okay, simplify பண்ணீங்கன்னா d gamma by d theta மட்டும் வெச்சிட்டு மத்தெல்லாம் ரைட் ஹேண்ட் சைடு கொண்டு போனீங்கன்னா you will be getting ad sin theta divided by bc sin gamma கிடைக்கும். Okay, now tell me for which case you will be getting the minimum and maximum value. So we are having two extreme conditions when theta equal to 0 degree and theta equal to 180 degree. Correct or not? Okay, either theta வந்து ரெண்டும் 0 ஆகணும், இந்த ஈக்குவேஷன் வந்து 0 ஆகணும் அப்படின்னா you can substitute theta value as 0 or 180 because it is in sin. Okay, so sin theta sin 0 0 ஆயிரும் இந்த equation, whole equation, or sin 180 போட்டீங்கனாலும் இந்த equation 0 ஆகணும். So for that case only you will be getting the minimum and maximum transmission angle. Okay, if it is sin 0, okay, now tell me what is the orientation of your 4-bar mechanism. Sin theta வந்து 0 ஆ இருக்கிற பட்சத்துல what is the orientation of your 4-bar mechanism? If you are able to understand this, definitely you catch the concepts behind the transmission angle. So ரெண்டு கேஸுக்கு
Sir, angle between
yes,
sir, gamma is also 0.
gamma விட்டுருங்கப்பா, gamma தான் கண்டுபிடிக்கிறோம். இப்போ தீட்டாக்கு எந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணோம்னா உங்களுக்கு வந்து இந்த ஈக்குவேஷன் 0ன்னு பார்த்தீங்கன்னா சைன்ல இருக்கிறதுனால இதை 0 sin 0 போடலாம் or sin 180 போடலாம், so that it will be 0. Okay, this whole equation will be 0. For this, you will be getting two conditions. So theta will be 0 or theta will be 180. In the case, in the equation 0. So theta வந்து 0 ன்னு assume பண்ணிட்டீங்கன்னா உங்களோட orientation of your 4-bar mechanism எப்படி இருக்கும்? லிங்க் எப்படி ரொட்டேட் ஆயிருக்கும் இப்போ? theta 0 அப்படின்னு என்ன அர்த்தம்? So here it is theta.
சேம் லைன்ல இருக்கணும் சார்.
எதுக்குப்பா? எதுக்கு சேம் லைனா இருக்கும்?
இந்த
ஃப்ரேமுக்கு.
Yes, exactly correct. Frame கூட same orientation இருக்கும். So assume this is your frame and this is your crank. So இப்பதான் theta 0, கரெக்டா?
Yes, sir.
Yes. Then அதுக்கப்புறம் உங்களோட கப்ளர் அண்ட் சம்வேர் ராக்கர் இப்படி கனெக்ட் ஆயிருக்கும். ஸோ இப்போ இந்த கேஸில் தான் உங்களுக்கு வந்து மினிமம் டிரான்ஸ்மிஷன் ஆங்கிள் கிடைக்கும் when theta equal to 0. Okay, it is shown in here also. இது பாருங்க, crank வந்து it is in line with the frame. So crank is 2, it is in green color. So here theta is 0. When theta is 0, your crank is in line with the frame. So in this case, you will be getting gamma minimum transmission angle. Okay. Maximum எப்போ கிடைக்கும்? Maximum transmission angle எப்போ கிடைக்கும்?
அந்த லிங்க் வந்து பேரலலா போயிருக்கும் சார்.
Yes.
சார் பேரலல்னா அதே லைன்ல ஆப்போசிட்ல இருக்கும் சார்.
ஆப்போசிட். அத கண்டுபிடிச்சிட்டோம். முன்னாடி பாத்தீங்கன்னா 0 and 180 டிகிரின்னு கண்டுபிடிச்சிட்டோம் இல்லையா? தீட்டா வந்து 0வா இருக்கும்போது மினிமம் டிரான்ஸ்மிஷன் ஆங்கிள் கிடைச்சிருச்சு. இப்போ அடுத்தது 180 டிகிரி. ஸோ 180 டிகிரினா எவ்வளவு? ஃபார் எக்ஸாம்பிள் ஃப்ரேம்ல இருந்து இட் இஸ் மேக்கிங் 180 டிகிரி. ஏர்லியர் வந்து கிராங்க் கூட மெஷ் ஃப்ரேம் கூட மெஷ் ஆயிருக்கு. ஸோ 0 டிகிரி. நவ் theta is equivalent to 180 degree. So in this case, you will be getting crank is opposite to the frame. So in the 180 degree make பண்ணிருக்கும்போது now you can able to observe the difference between the minimum and maximum transmission angle. So when theta equal to 0, the crank is in line with the frame. So you will be getting the minimum transmission angle. When theta is equivalent to 180 degree, the crank is in straight line with the frame. So you will be getting the maximum transmission angle. So in the orientation, whatever the force you are applying through the coupler is going to be effectively transferred to the motion of your coupler. I'm sorry, rocker. Clear?
Yes, sir.
Any doubts in this?
சார் இது வந்து இந்த மெக்கானிசம் மட்டுமே இது அப்ளை ஆகுமா இல்ல எல்லாத்துக்குமே இந்த 0 to 180 தானா சார்?
No, it is depending upon the mechanism what we are using. Okay. Or sometimes in the 4-bar mechanism நம்ம different orientation வச்சிருப்போம். For example, instead of keeping the frame, okay, let me draw it here. Frame வந்து இங்க இருக்கு O2, here O4. So it is a 4-bar mechanism. Sometimes your O4 may be shifted. Okay, from O4 மேல இருக்கலாம். This is your O2. O4 இங்க இருக்கலாம். Okay, some offset in the distance இருக்கும். So in the case க்கு வேற orientation கிடைக்கும். So it cannot be applicable for all the 4-bar mechanism. So depending upon the offset conditions or orientations of the mechanisms, it will vary. The minimum and maximum transmission angle will vary. So simple 4-bar mechanism, this is the case. Clear?
Yes.
Okay. How can we write the equations for the transmission angle for this particular case? So we can apply the cosine law for the first case. So in the first case, write the cosine law. Cosine law எப்படி எழுதுவீங்க? Tell me. We need to find out gamma minimum. We know when theta equal to 0, you will be getting the minimum transmission angle. And when theta is equivalent to 180 degree, we are getting the maximum transmission angle. But we are interested in finding out the magnitude of gamma. Okay, in both cases. Magnitude kanna evlo value, evlo degree-ங்கிறது எவ்வளவு கண்டுபிடிக்கணும். அப்படினா we need to use only either analytical approach or graphical approach. First, let me brief how to proceed with graphical approach. Graphical approach என்னப்பா பண்ணணும்? We need to draw according to the scale of that is a 4 bar mechanism. So in over link என்ன dimensions கொடுத்திருக்காங்களோ that we need to draw and we need to measure the gamma minimum and gamma maximum. For example, you take the dimensions of crank, coupler, rocker and frame are two suitable dimensions. So அதுக்கு வந்து minimum and maximum transmission வேணும்னா first minimum transmission angle வேணும்னா first you need to draw the frame. So frame ஓட dimensions எவ்வளவோ அந்த dimensionsக்கு you need to draw. So O2, O4 as per scale. For example, 5 cm or 10 cm எவ்வளவு கொடுத்திருக்காங்களோ that we need to draw. Then அதுக்கப்புறம் என்ன பண்ணணும்? Next என்ன பண்ணணும்? frame வரைஞ்சாச்சுப்பா. frame ஓட length கொடுத்தாங்க வரைஞ்சாச்சு. அதுக்கப்புறம் என்ன பண்ணணும்? crank வரையணும். கரெக்ட்டா? crank வரையணும். crank ஓட length வந்து for example 6 cm. So for example இது சென்டிமீட்டர் 10 cm னு வெச்சுக்கோங்க. crank ஓடது 6 cm னு வெச்சுக்கோங்க. or otherwise 5 cm னு வெச்சுக்கோங்க. So for minimum transmission angle, so இந்த O2 வெச்சிட்டு இங்க இருந்து 5 mm க்கு we need to draw 5 mm க்கு we need to draw another line. So உங்களோட crank இங்க முடிஞ்சிரும். கரெக்ட்டா? Okay. Next என்னப்பா வரையணும்? Next coupler வரையணும். We need to draw the coupler. Coupler dimension for example 7 mm அப்படினா you start this as center point and you make an arc for 7 cm and you know the rocker length தெரிஞ்சிச்சுனா இங்க இருந்து you need to draw the another arc consisting of rocker dimension. Okay, இந்த பாயிண்ட் கிடைச்சிரும். So இது ரெண்டே கனெக்ட் பண்ணிட்டீங்கன்னா if you connect these two you will be getting what is the angle this one?
minimum transmission
angle கிடைச்சிரும். இது maximum transmission angle வேணும் என்ன பண்ணணும்ப்பா? maximum இதே dimensionsக்கு
Opposite.
yes, first you need to draw the frame. So this is O2 O4 and you need to draw the crank வந்து என்ன பண்ணனும்? இந்த opposite side இங்க வரையணும். வரைஞ்சிட்டு then you know the coupler dimension, you know the rocker dimension. So coupler வந்து இங்க இருந்து கனெக்ட் பண்ணி இங்க இருந்து ஒரு arc அந்த dimension கிடைக்கும். rocker ஓடது இந்த எண்ட்ல இருந்து you need to draw an arc of rocker dimension. Connect these two. In this case, the angle you will be getting
maximum transmission.
It is mu max. Maximum transmission angle கிடைக்கும். It is mu max கிடைக்கும். So what type of approach it is, pa? What type of approach it is? Approach வந்து it is graphical approach. நம்ம graphical approach வரைஞ்சு we are able to find out the minimum and maximum transmission angle. So or otherwise we can use the analytical approach. Okay, it is graphical approach is one of the approaches. It is very simple for simple mechanisms, whereas another approach is analytical approach. We need to use some formulas to find out the minimum and maximum transmission angle. So the formulas are not new to us. So we know how to write the cosine formula for triangles. Now first case gamma minimum ku consider this particular triangle. Okay, in the triangle மட்டும் consider பண்ணிக்கோங்க. So this is the minimum transmission angle. So இதுக்கு cosine law எப்படி எழுதுவீங்க? Tell me the cosine law for this triangle. Tell me the cosine law for this triangle. Cosine law என்னப்பா? ரெண்டு சைடோட ஸ்கொயர். Okay, first we need to write the side square, that is AB square plus BO4 square minus 2AB and BO4 cos gamma in the sense it is giving minimum transmission angle, correct? Gamma minimum is equal to what? Is equal to what, pa? அந்த ஆங்கிளுக்கு ஆப்போசிட் இருக்க சைடு எதுப்பா? this one. Am I right or not? What is the name for this?
AO4 square.
Exactly. AO4 square, or time being let me keep it as x square. So இது வந்து x ன்னு வெச்சுக்கிறேன். AO4 வந்து x ன்னு வெச்சுக்கிறேன். Okay. Now cos gamma தவிர்த்து மத்ததெல்லாம் இந்த பக்கம் போனீங்கன்னா, I'm sorry, gamma தவிர்த்து மத்ததெல்லாம் இந்த பக்கம் கொண்டு போனீங்கன்னா you'll be getting what? This equation. Okay, so gamma மட்டும் இந்த பக்கம் left hand side retain பண்ணிட்டேன், மற்றதெல்லாம் right hand side கொண்டு போயிட்டுனா you'll be getting this one for getting the minimum transmission angle. Okay, for getting the maximum transmission angle also the same equation can be used. இதே equation யூஸ் பண்ணிக்கலாம், பட் x என்னவாகுங்க? xங்கிறது என்னப்பா? for minimum transmission angle xங்கிறது x are opposite sideங்கிறது என்னப்பா? this AO4, correct or not? O4. For maximum transmission angle, what could be the change in x?
Sir, AO2.
AO4 தான், but it is a larger dimension. So முன்னாடி வந்து ஒரு 5 mm 5 cm பண்ணிருந்தீங்கன்னா இப்போ ஒரு 10 cm இல்ல 15 cm
frame plus crank, sir.
Yes, exactly. Yes, yes, exactly correct. Frame plus crank. அதோட டைமென்ஷன் சப்ஸ்டிட்யூட் பண்ணும் x க்கு. மற்ற டேர்ம்ஸ் எல்லாமே சேமா வச்சுக்கலாம். x க்கு மட்டும் ஓகே, x க்கு மட்டும் மேக்ஸிமம் டிரான்ஸ்மிஷன் ஆங்கிள் கண்டுபிடிக்கிறதுக்கு ஃப்ரேம் லென்த் பிளஸ் கிராங்க் லென்த் சப்ஸ்டிட்யூட் பண்ணும். whereas மினிமம் டிரான்ஸ்மிஷன் ஆங்கிள் கண்டுபிடிக்கிறதுக்கு ஃப்ரேம் லென்த் மைனஸ் கிராங்க் லென்த் சப்ஸ்டிட்யூட் பண்ணணும். கரெக்ட் ஆர் நாட்?
Yes, sir.
Yes, it is analytical approach. It is analytical approach, which is easy. Analytical approach or graphical approach?
Graphical.
Yes, graphical approach is very simple, but என்ன வரும்னா some errors. Okay, some while drawing you need to draw accurately using mini drafter so that you will predict exactly what will be the minimum and maximum transmission angle. If you slightly deviate the lines while drawing, you will be getting some deviations in your answers. But the analytical equations are going to give the exact solutions for minimum and maximum transmission angles. You can compare these two. Okay, whether you are getting correct answers or not, we can make a cross check. Clear?
Yes, sir.
Okay, any doubts in today's class?
கொசைன்ல எப்படி பண்ணணும்னு சொல்லி தெரியுங்களா சார்?
கொசைன்ல எப்படி அப்ளை பண்றதுன்னா
கொசைன்ல சொன்னீங்க சார், ஒன்றும் புரியல சார்.
Let me repeat it again. Suppose if you are having one triangle அப்படின்னா, so this is your angle. So இந்த angle தான் நம்ம பார்க்கணும் அப்படின்னு வச்சுட்டீங்க வச்சுப்பா. Okay, this is your gamma அப்படின்னு வச்சுட்டீங்கன்னா கொசைன்ல எப்படி அப்ளை பண்ணணும்னா, suppose if you are take this A, this is B and this is C. ஸோ இதுக்கு கொசைன்ல எப்படி அப்ளை பண்ணணும்னா, ஃபர்ஸ்ட் இந்த ஆங்கிளுக்கு அட்ஜஸ்டன்ட் ரெண்டு சைடோட ஸ்கொயர். ஸோ A ஸ்கொயர் பிளஸ் B ஸ்கொயர், அதுதான் அந்த ரெண்டு ஆங்கிள். ஐ மீன் இந்த ஆங்கிளுக்கு இருக்கிற அட்ஜஸ்டன்ட் சைட்ஸ் A ஸ்கொயர் அண்ட் B ஸ்கொயர். அது ரெண்டையும் ஸ்கொயர் பண்ணிட்டு மைனஸ் 2AB cos gamma. That should be equivalent to the opposite side square. இந்த ஆங்கிளுக்கு ஆப்போசிட் என்ன இருக்கு? C. இந்த C ஓட ஸ்கொயருக்கு ஈக்குவலா இருக்கும். So this is your cosine law. You can use any triangles, you can apply this law for finding out the transmission angle. The same concept is used for finding out the transmission angle for minimum and maximum conditions. Is it clear? Okay. So this is a mathematical formula. Okay, you can recall. Any doubts up to this? Any doubts? Any other doubts?
No, sir.
Want any clarifications? Ask me.